Hi, everyone, and welcome to our next in our series of our seminar series from the Big Data AI Hub at the Institute for Management and Innovation. And today we have with us Mark Dymond, who's a senior partner and Canadian leader in hybrid cloud services from IBM, and Cynthia Unwin, who's executive architect, hybrid cloud and site reliability in engineering. And they are going to talk about the hybrid cloud. So I'm going to turn it over to you, Mark.
Hi, thanks very much, Irene, and thanks very much for having us both. Let me just add a little bit to that introduction. So I'm Mark Dymond. I lead for IBM Consulting. I lead what's called the Hybrid Cloud Services team, and that includes all manner of technology-oriented consulting around on AWS, on IBM Cloud, on Azure, on Google Cloud, whether it's designing or building or migrating to cloud and managing in that environment as well. I'm a graduate of the University of Toronto, not the Mississauga campus, I'm afraid, the downtown campus in electrical engineering. And I'm here today, delighted to be here today with my colleague, Cynthia Unwin, and I will let Cynthia introduce herself.
Good afternoon. My name is Cynthia Unwin. As Mark says, I am an executive architect with the Hybrid Cloud Services practice in Canada. I do a lot of work, hands-on work with teams that are actually building solutions on hybrid cloud solutions, and do a lot of working with composing applications and troubleshooting and making sure that they're reliable and resilient over the long term.
Okay, thanks, Cynthia. I will share that we have a few slides and a couple of demos. Can you see? I just want to make sure you can see the presentation. I guess you can tell. Can somebody give me a thumbs up that you can see the slides? Awesome, thank you. Okay, so wanted to just go through a couple of topics here. First off, what is cloud computing and what is hybrid cloud? Explain those items. We'll talk a little bit about what big data is from our perspective, and then how cloud and big data work together to really get you the best outcome, and then hopefully a few lessons learned and best practices. So that's what we'll go through. We do have a couple of demos, and as I was saying in the pre-meeting just before we got started, they are live demos, and so when it's live, there's always a question of whether it's really going to work, if there's some connection out to the internet that works or doesn't work at the last minute. So we'll see how that goes, and hopefully everything will go well. We had a lot of challenges during the dry run, so maybe that means that it'll go really well today. Okay, so let me start with a little bit about what is cloud computing, and I really I want to explain maybe by going backwards a little bit. So companies have been using computers for about 50 or 60 years, which is not really a long time in the history of how corporations have run. And for the vast majority of that time, up until the last few years, all the technology was owned by the company. And each big organization and most little organizations would have their own computing center, data center, a computer room. There were a couple of different names for it, but a big center with air conditioning and all of their centralized computing power in that one room. And that worked really well, for certain things, but there were things that didn't work well for. And the thing that it didn't work well, or the thing that worked the least well for, was change. If you had, for example, annual report that had to run that used a lot of computing power or required a lot of storage, you had to size your environment so that because you owned all that equipment in that center, you had to basically have that capacity all year round. And it took a lot of lead time to put in new resources. Those servers, companies like IBM built new equipment. They said, oh, you've got this new faster thing. You were constantly having to buy new technology and upgrade it. It was a very resource intensive part of IT, and very time consuming, and required a lot of resources in the IT department to run. By the way, most large organizations still have 50 or 60% of their technology still runs that way. But about 10 years ago, this new paradigm, to use a very overused word, this new paradigm came out, which was cloud computing. And probably most of the technology that you use today uses cloud computing. Anything new being built is on the cloud. And what the cloud is, there's still a data center somewhere, by the way, but it's all centralized and all virtualized so that you as the consumer, whether the consumer is a corporation or an individual, can achieve on-demand resources. So instead of having to have my IT department figure out how much space they're going to need, how much computing power they're going to need, how much memory they're going to need for each application, I can use it. I can acquire it on demand. And if I need more for that one-time thing that happens maybe at quarter end or at year end, I can access that. And when I don't need it, I don't have to access it. When you think about, it's the difference between owning a car and ordering an Uber, right? When I own the car, I have to worry about buying gas, and I have to worry about parking, and I have to worry about insurance, and I have to worry about driving. And when I order an Uber, I don't have to worry about those things. And just like the car, I drove to work this morning, the car sitting completely idle for 9 hours, and then at the end of the day, I'll use it again for 20 minutes. It'll be idle for another 10 hours. As opposed to an Uber, which is I'm using it now, and then somebody else is using it later. The total resources available are used more efficiently because everyone's using the same pool of resources, and you're using it when I'm not, and I'm using it when you're not. So that's the basic difference, and it really is fundamentally changing how IT departments work and how they meet the needs of their users. And so, if you're looking at the chart, all these different websites from different cloud providers basically have the same definition. It's you scale up and down to meet demand as you need it, and you only pay for what you need. And in a lot of ways, it's self-service. You can get the resources when you need without the need for complicated senior technical people to manage that component of it. So when we look at the cloud, there's a number of different providers. There's a number of different layers of how much is cloudified. And the IT industry loves to use a lot of acronyms. And then, by the way, we torture the acronym and make and turn it into a word. So they talk about the layer of technology that is provided as a service. AAS is as a service. And the basic layer is infrastructure as a service. And the best example of that for you would be like iCloud or Dropbox, which is an infrastructure as a service provider for a storage space. So it works exactly like your hard drive on your laptop, if you still own a laptop, and or your desktop unit, and it just provides additional space. And if you want more, you just up the amount that you're paying to Apple or to Dropbox, and they provide you more space. The next layer is called platform as a service, and that's where they basically provide a computing environment with more than just the physical capabilities. They actually provide a level of development tools, et cetera, to allow you to run applications. And then the top layer, if you will, or the most advanced level of service is where they provide a solution as a service or software as a service. And those are tools like Salesforce or Workday or SAP. In the consumer space, a great example would be the Google Apps or Office 365, which are applications that you can use. You download, you're downloading it while you're using it, but all the application is stored in the cloud. All your information can be stored in the cloud as you're working. And when we talk about the cloud, we actually, people have a tendency to talk about the big three providers of services: Amazon, Microsoft, and Google. And then, when we start thinking about, the SaaS providers at Salesforce and Workday, and Oracle Cloud, for example. But in fact, when I checked this, it was probably a couple of months ago now, that I'm sure it's gone up even more. There's over 20,000 companies providing a cloudified service of some description or not. A great example in the consumer world is Netflix, right? We used to, you guys might not even remember this. We used to go to a store to buy or to rent a movie, and you would have to physically take that back. And now, of course, we just stream these things, whether it's from Netflix or Disney Plus or whoever. And so the point is, it's really quite pervasive in our in industry and in our personal lives. But in industry, we're really going through a transition because we have all this installed base of technology that runs the core components of our business. And when you implement things on the cloud, all of a sudden you've moved from something that I, as a company owner, or as the CIO, the head of IT, as I control the whole thing. There's a data center. I have people who run that data center for me, and they're responsible to me, and I know exactly what they're doing about security and about the latest versions, and making sure that we're using the latest or deciding not to use the latest versions of software. And when you move to the cloud, you gain flexibility, but you lose that control. Now you've given that control over to Amazon or Microsoft or Google or whoever. And so that's part of the transition, because most IT departments, they start that transition with using very simple applications, very low risk applications, and gradually move more and more to applications that are more sensitive to their core business, right? So what cloud really provides for us is a tremendous amount of flexibility. It gives us the new capabilities in the corporate world around taking away work that we need to do in the IT department and moving it into a centralized function where it can become more flexible. And what that gives the corporation is cost flexibility, because you're only paying for what you need, and the ability to scale up and down and react much more quickly to the market. In many ways, it's created completely new business models. So, and a great example, and I mentioned it already, is Uber. And Uber really started with no data center, no technology, with 4 existing APIs. They're called application components that existed on the cloud that you could buy. A location identifier, a billing item, a billing technology, and a mapping technology were 3 of the 4. And that created a whole new capability that didn't exist before around ride sharing, and totally destroyed the taxi industry, right? So this flexibility drives new innovation and new ways of doing things. And it also has the opportunity for businesses and individuals to build much deeper relationships with their stakeholders, whether those stakeholders are the shareholders or the customers of the business. So it really is transformative in how things work. And when we look at Canada particularly, obviously, or maybe not obviously in my industry, the pandemic really sped up cloud adoption because people that couldn't go to the office, they realized that I don't need people in my data center. I might as well have this on the cloud. But we're still struggling with getting the maximum benefit out of it. And when we talk about the maximum benefit, we typically talk about as digital transformation or business transformation. And in Canada, and this is data from about this time last year, by the way, we do the survey every year. We're doing it right now, so this data is about a year old. But basically, in Canada, only 1/3 of organizations feel that they're really there in terms of getting a true digital transformation, the true power of the cloud. And we're going to talk about hybrid cloud, I think, in the next couple of charts. But hybrid cloud has become the dominant architecture for us. And as I said, organizations are about midway on this transformation of moving to the cloud and building applications that really take the most advantage of the cloud. And the highest concern that people have is around security. And it goes back to what I said before. You're moving the data out of a physical space that you control into this place that someone else controls. And on the one hand, that's really scary. And if you read the news or listen to the if you listen to the news, you frequently hear about security breaches and data loss, or data becoming public, or somebody hijacking data. But I would say that's actually much like airline disasters. You hear about airline disasters that happen all over the world because airline accidents are actually quite rare. And that's why you hear about it when it happens in Malaysia or Australia or wherever it happens. As opposed to car accidents, which kill far more people every day, but are frequent. We never hear about car accidents that happen in Australia or Malaysia or Africa because they happen way too frequently. So when we talk about these cloud breaches or whatever, the reality is the cloud is more secure because you have some organization whose full-time job it is to run that center, that cloud data center, wherever it is, to make sure that all the controls are in place for all the clients that are in it. I've touched on this a little bit, but cloud is really one, and big data, which we'll talk about in a second, are really only a couple of the really transformative changes that are happening that are really fundamentally changing how business and IT work together. And as somebody who's been in IT consulting for most of my career, I have to say it's a super exciting time to be in this world, because so many things are changing at once, and there's tremendous opportunity to learn and to do things that maybe we've always wished we could do. So some of the things that are changing the world are cloud and big data that we've already talked about, machine learning and artificial intelligence, the provisioning of SaaS offerings, but also things called robotic process automation, which is basically taking away the routine IT functions and automating the routine business functions and automating them and having basically digital workers. IT has traditionally been really focused on having a development team and having an operations team. One is around change, one is around not change, and concepts like DevOps, which merge those capabilities together, site reliability engineering, or SRE, new technologies like 5G. All of these are changing the way that IT works with the business. They're all constrained by a few things. The big one is that our legacy installed base, which is generating a lot of inertia. And the other big one is ensuring that you are financially and regulatory in compliance, right? Is the new function going to be auditable, and are we putting our data at risk? And then there's a constraint around what happens in the industry. But what's pushing us to implement all of these things, frankly, is our stakeholder expectations. We want every function in IT to be as simple to use as your iPhone or your Android phone. When you think about it, you download an app, no one ever teaches you how to use that app. It's just intuitive, right? We all pick that up. I will tell you, there's whole departments for training people on how to use the IT systems in an organization. And so moving with all of these capabilities at once is our attempt to meet that expectation. And again, as a lifetime IT consultant, I often joke that Apple didn't do us in the industry any favors when they made it so easy. They made everything look so easy, because it actually is really hard to get all those things working together. Excuse me. So I talked about cloud, and I want to kind of bring all that together by talking a little bit about hybrid cloud. So hybrid cloud, which is a term you hear a lot. You also hear multi-cloud a lot, and I'll explain both those. But basically, I talked about those on-prem environments or on-premise environments in the corporate existing data centers. Hybrid cloud, at its most basic, is when that cloud application that you've built or that you've moved interacts and exchanges information with the on-premise environment. And it's multi-cloud when an application, say on AWS, talks to an application on Azure or IBM Cloud. And so we also talk about hybrid multi-cloud in that way. But really, the solution there is to have a hybrid cloud platform, and that is building with a common environment where you're using the same technology on premise and you're using the same technology in the cloud. And that allows you to build applications one time and have the single set of skills in your organization, and yet access the innovation that exists anywhere. And again, I feel like I have to do a bit of a history lesson when I do these things. But when I first started in computing, there were these things called mini computers, which were departmental level servers that the finance department would have one, the HR department would have one, and the supply chain department would have a server. And they would all have different servers built by different companies, and they didn't talk to each other. And it made it really complicated. You had to have different IT functions with different skills that didn't necessarily know how to work with each other's technology. And the solution to that problem, back in the day, was that all of a sudden they all started using, or over a relatively short period of time, they all started using Unix as their operating system. So Unix, they all ran Unix. They all used a common database technology like Oracle or Sybase, and they all used common development tools. And all of a sudden, those servers that used to be very difficult to talk to each other were connected by the same technology called the same networking technology called TCP/IP, and then all of a sudden it became much more easy for those systems to work together. And to a certain extent, we have that same problem today, which is if you build something and it's AWS native, it's not easy to move that to Azure 5 years from now when you're unhappy about how Azure works, about how AWS works. And if you build something that's Azure native, you can't move it to AWS or to Google or IBM Cloud. And so if you build it on a common platform, you're able to get the access to the interesting things that are in Azure and the interesting things that are in AWS, but you don't. But you have a common environment and you have common skills for all your development team to work with. So basically, everybody's hybrid because they all have systems on-prem or on-premise and on the cloud. And the real innovation comes when they have a common technology environment that allows them to use the same tooling in the cloud and on their on-premise environments. So I'm going to turn it over to Cynthia now, who's going to talk about, who's going to start the demo and talk about one of the most critical components that make that hybrid cloud world work, which is composability.
Excellent, thank you so much. Okay, so one of the things that is really revolutionary about working with multi-cloud and hybrid cloud is the ability to form applications from different pieces that already exist, much like you would in an automatic manufacturing thing. When you manufacture a car, they don't go out and start from scratch and rebuild every part for every car. There are a certain number of parts that fit together in a certain way, and they recompose that into a new model. This is what we're seeing is the pervasive trend. And when we're moving forward with multi-cloud applications, it's the as much as the scalability and the ability to spin up compute really quickly is exceedingly powerful. And that was how we started with moving to the cloud. What we're seeing now is a trend towards these composable applications where you take the best of breed in applications and you put them back together as a single unit that does something different. Next slide. Okay, and then what the moral on this topic, the composability model really democratizes the access to services. You can put things together. You don't need to have a tremendous amount of skill in any one thing. You don't have to have that deep depth of knowledge in every area. Just like Mark was saying about Uber composed itself out of 3 or 4 services. They didn't need to know how to do the geolocation. They didn't know how to need to know how to write the billing application. They just needed to know how to put them together into something new that was revolutionary. And you see the power of that. And we're using the IKEA model here to show that ability to take the pieces and put them together and make them into something that's a whole. So the multi-cloud model allows for this, and it really enables that ability to put things together however you need them to do something completely different. Next one. And so then we're going to do a demo, and I'll share. I'll get you to show the one last slide, and then I will share. So what we're going to do here is, for the first demo, we're going to build a database-driven Slack bot in 7 easy steps. And we're hoping it's going to be 7 easy steps. So we're going to use a DB2 database that is a completely managed service. We are going to use a Watson Assistant, which is a service that is available on IBM Cloud. We're just going to configure it. We don't need to have any knowledge of how that actually works. And we're going to spin up a container on IBM Code Engine. And you'll notice through both of these demos, I'm not going to provision any compute for anything. I'm just going to use existing services. So we will use the serverless platform that exists on IBM Cloud. There's one on every major cloud. That would be the glue that ties the Watson Assistant to the database, because that container knows how to select things from the database and write to it. And then what we'll do is we'll go out to a completely different cloud, which is Slack. And we will use the Slack service to talk to the Watson Assistant that will then follow this whole path through to our database. And we'll be able to ask questions and get answers back from our Slack bot, at least ideally. Okay, so I will share my screen. Okay, so where we're going to start here is down here to my picture. So we're going to start with these pieces that are on the IBM Cloud. So here we are. This is my IBM Cloud account. And we can see here that I have this event DB here is a DB2 database that I created for this demo. It takes about 3 minutes to spin up a database on IBM Cloud. Provisioning is exceedingly quick. I can put them up, take them down in a matter of minutes. In addition, I have already provisioned the event assistant. Provisioning an event assistant takes 4 or 5 minutes. It's in the grand scheme of things, it's very quick, but I would prefer for us not to have to wait for that right now. So if you remember from the picture, we are going to take the database that is here, and we're going to connect it to the event assistant. And we're going to do that by spinning up it's just a Docker image that was pre-built for this purpose. And we're going to, I need to switch cheat sheet here, because we don't want to fumble through my commands here. And we're going to create the container on the IBM Cloud. So you see what this is. We're using the IBM Cloud CLI, and we are
Command line interface.
Command line interface.
We use a lot of acronyms in this business.
Yes, I'm terrible. I don't even notice. Okay, so we're using the command line interface. I've already logged into the IBM Cloud. We're telling it that we're going to use the IBM Cloud. We're targeting the IBM Code Engine, which, as I said, is the serverless platform. And we're going to create an application, and we're going to call it Slackbot Backend 2. And we're going to use this image that was a pre-built image that was actually a pre-built image for connecting Watson Assistant to a DB2 database. We've got an API token, and then here is the connection string that allows the container to know where the database is. So we commit that. And I think one of the really powerful things that I wanted to come out of this demo is that I've created this, and I didn't have to go and spin up a server. I don't have to worry about how it scales. This is going to scale on its own. It's there's no provisioning of hardware. I have no knowledge of I don't know what it's running on in the back end. I don't know what's back there, and I don't need to know. And all I need to worry about is how I compose my application. So we're going to need this here for farther along in the demonstration. So I'm going to copy that. That is just the address of where the container that we just created is. So I'm going to take that, stick it down here. Come back to that in a moment. Okay, so then we need to go back to our IBM Cloud. And now we want to connect the event assistant to the container that we can look at it here. We just spun up. And there's the Slackbot backend too that we just created. And if we go back to our resource list, we can open the event assistant. Event assistant when it starts moving. Go. Launch that. And the first thing we're going to want to do is tell it where that container that we just built is, so it knows how to talk to the database. So we go into integrations. We build a custom integration or custom extension. We are going to call it new events. We're not going to bother with the description today. We really should, because when I come back 6 months from now and think, what on earth is that? I won't remember. Next, now, the assistant needs to know the definitions of all the APIs, so the application interfaces that the application programming interfaces that that container has that know how to talk to the database. So there's an open API specification that we can use, and I've created a file that knows what that specification is, and you'll see what that does for us when we get to the next step. We load that, and that file has just told the integration here how you use a get and how you ask for all events and how do I look for an event record by name. So we've supplied that to the integration, and we click finish here, and then we add it to our project. So we are going to use API authentication. And when I started this, I used a silly key, and now I'm stuck with it forever. And now the server variables, I was in Dallas earlier this week and created all the resources in Dallas. So that's why we're using those. Now we need to go back and pull that URL that I had earlier. That's this one here. And we are going to take the name of the application, which was Slackbot backend 2. We're going to put that in our application name. And then we're going to pull out the project ID, which is this weird number here. And we just know that that's how that URL is composed. And we feed that in as the project ID. We click next and finish. And now, with any luck, our assistant knows how to talk to the database. So now let's test whether it can. So we create an action, and I'm going to just create a new action here, starting from scratch, and all the action find and the event. So the database that we have has a list of conferences or seminars in it. And so what we're going to do is ask the Watson assistant to find a specific seminar for us and give us some details. So to do that, and now the Watson assistant is designed to create chatbots, and it is a rules-based AI model. There are various generations of AI models. If we're looking at some of the more recent work that's based on foundational models, it's much more sophisticated than this, but this gives us a good idea of how simple this can be. So we start out with the phrase that the customer enters is something along the lines of find an event. We can, the more I put it, the more phrases I put in here, the smarter the chatbot gets, but we'll know what to put in for now. So, and then when the assistant here's the message, it responds with what is the event name? And then we allow the customer to respond with free text. And then we continue to the next step. In the next step, we take that and we pass it to the extension that we just created. So this will then go out and make the call to the database through the container that we made. We're going to choose an operation, and the operation we're going to choose is event by record name. And short name. And we're going to set it to whatever we typed in when we were asked, what is the event name? Apply that. We're going to create one more step. We're going to put a condition on it that if that ran successfully, we are going to say the event details are name. We're going to put in the variable that we just pulled back. Short name and the location. Now we could fill in all of these things, but I don't think that's any more instructive than we have here. And then once that's done, we are going to end the application. So now if I were doing this, if I were really building a chatbot here, I would put in some error handling and I would tell it what to do if it couldn't find the name or all of these things. But for now, we'll just leave it at this. And then we can quickly test it. So I want to find an event. So it asks me, what is the event name? And I say, I don't know, I'm looking for a tech conference. It goes out to the database. And if we're very lucky, it will know. And yes, there we go. And the event details are IBM Tech 2023, and it occurred in Dallas, Texas. Okay. So now that's all well and good, but nobody wants to test it using use it using my test interface. So now what we're going to do is we will go out to Slack. And in preparation for this, I created a Slack application. It's easy to do. You log in, you go to your apps, you create one, and I enabled some events that it listens for. So I enabled it to listen to incoming messages, app mentions, messages and channels, things like that. And I gave it the ability to respond. So now we can see, and then we went, sorry, there's one more step. I told it where the assistant is. That's in our event configuration. So now when we go to Slack, we can see that if we talk to the application, we can say find an event. And we get the what is the event name. And I have to specify that I'm talking to it. It doesn't know to listen to everything on the channel. That was a security precaution because I have a limit of how many interactions I can use. And let's look for Think. And there we go. And we get the event details back from the database, Think 2022, and that was in Boston.
So, okay, so what we just saw, just to be clear about how what's all happened, is on one cloud we've created a simple chatbot that responds to locations of various conferences, and on another, and we've connected it to a different cloud, the cloud that runs Slack, and been able to access between them. We didn't have to think about how much technology we needed, how many how big the database was going to be to store all those records. We didn't have to think about how fast it had to work and how much compute power it needed. We didn't have to think about any of that provisioning information. Obviously, in the interest of time, it's an incredibly simple demo. Excuse me, but it's basically giving us the showing the power of making these two clouds work together and having access to one technology through another technology. Is that basically right?
Basically right. And we just in addition to that, I don't know how the Slack application works. I don't know how the Watson Assistant works. I have a fair idea of how the container works. And I have no knowledge of the implementation of the database, but I put it all together and made it work as a single application.
Okay, awesome. Okay, let me go back to our presentation. I have to share, don't I? Let me share again. Okay, so I'm going to just do a quick level set, hopefully on big data. And like we did with cloud, we'll start with the relatively simple concepts and get into more complicated things, or as I like to say, the things that I understand and I can explain, and the things that I need to bring Cynthia into the conversation for. So, again, if you think about historically, 10 or 15 years ago, when you went to the store and bought something, they had very little information about you as the consumer. And then we got our Optimum cards and our frequent points cards, our Air Miles cards, etc. And they started to have more data about you because they could track that last time you were in, you bought this item, and then this time you bought these other items, and we can predict what maybe what you'll buy next year. And then when we went online, we got even more information because we started creating accounts, and we told them how old we were and where we lived, and et cetera. And all of that data, there's data that we provide, but there's also data that they can use that comes from other places. And so, for example, if I give an organization my postal code, they now know, they have data about all the other people who live in that postal code, and they can say, people in that postal code are more likely to be, active versus or sedentary. They're more likely to be high income or low income. They're more likely to be this ethnic group or that ethnic group. They have all sorts of information about you that they can then use to decide, what they would like to, what you might want to purchase, or what they might like to sell to you, or how they might better service you. And so that combination of the sort of transactional data that we've always provided, plus this contextual data, it really starts to drive the big data conversation. And I really want to highlight, like, the amount of data that's available is actually staggering. And there's over 1 billion Google searches that are made every single day. There's 300 billion emails that are sent every day. I feel like I'm copied on most of those. And there's thousands, tens of thousands of photos posted on Instagram. There's social, all sorts of other social media data. There's half, even in this crazy world that Elon Musk has created on Twitter, there's still 500,000 tweets every minute, and hours and hours of YouTube videos that are updated. And what's fascinating to me, and Cynthia and I were talking just before we started, there's about 8 billion people on the planet, and yet there's 8.6 billion mobile device subscriptions that people have. And so Cynthia was saying, well, how many people, like, I only have one. And then we started thinking about it, and between us, we have 4. Between the two of us, we have 4, even though we didn't realize it when we first started thinking about it. So there's just a ton of data that's available, that's coming from all of these devices. There's a really important concept that I kind of glossed over before about the Internet of Things, which is basically connecting devices to the World Wide Web, whether that's through the phone network or whether that's directly connected to a device. and having things like an AirTag is a great example of an IoT device. It's a device that helps track, whatever you attach it to. And so all of that data and figuring out how to manage all of that data is basically the big data opportunity. And, it's an incredibly powerful capability. An Accenture study suggested that basically every company agrees that big data is, competitive. It's a competitive advantage if you use it correctly, and it's a competitive disadvantage if you fail to execute. And so everyone is basically trying to figure out how to outperform everybody else. So let me explain what big data is, and really it's the three things in the middle of the. It's not just more data than we used to get. It's large amounts of data. It's predominantly collected passively. In other words, I'm not actually having to type in my postal code and my age. It's gathering the information without me really thinking about it, and coming typically at a great variety and at a high rate of velocity. So, one of the great examples is for a major Canadian railway. They added sensors on the rail cars to the wheels, and before they did that, they basically would say, we need to replace the brakes, whatever, every 1,000 hours of usage. But now, by measuring the temperature that the brakes get to and the wear on the wheel, they can be much more proactive and say, this rail car needs to come out of service early, maybe at only 800 hours. This other rail car, the wear is much lower. We can go 1,200 hours or 1,300 hours before we have to replace it. That means there's less likelihood of a problem, and therefore a more on-time delivery of goods. That also means that they're saving money where they don't have to repair things until it's needed. And then when they can start using that data with other data that they're collecting, and for example, say, when Mark's driving the train, we seem to always need it to fix the brakes at 800 hours. When Cynthia's driving the train, we get the 1,200 hours, and maybe there's something that Mark needs to learn from Cynthia about how to drive the train better. And so, and by the way, when we talk about these data items, and the one I just gave about the sensor data is actually the kind of thing that traditional data could have done, except they couldn't have dealt with the volume. But many of the other items are things that are unstructured data that are complicated and not the way that IT systems have traditionally looked at data, which is very rigid. You think about your address. It's got a number, it's got a street name, it's got a street type, it's got a city name and a province name and a postal code. Those are things that are very structured and very simple. But unstructured data is the second house on the left after you turn at the light. That's the type of data that you're collecting through, in big data. You're getting all sorts of information, some of which is very rigid, and some of which is very fluid. That's really why we need the cloud in order to manage it, which we'll get to in a second. So when we talk about big data, they really talk about 4 V's. And if you actually start Googling this, you'll find there are some people that say there's 6 V's, and there's some people that say there's only 3 V's. But really, I think the consensus is we talk about 4 things that really make a big data project successful. The first one is accuracy or veracity. So how trustworthy is the data that you're collecting? Are you curating the data and making sure that, in fact, it represents real information? Obviously, I've kind of already highlighted that the second one is volume, and that we're talking about huge volumes of data that are coming every day, every minute, and that you have to be able to continually expand the amount of space that you have available to it. And then a variety is the third one, and that's really about data that's collected actively, data that's collected passively, data that's coming from video, data that's coming from sensors, data that's coming from all sorts of different sources. Excuse me. And then finally, it's velocity. It's the ability to intake all of that data and analyze it. All of these things were happening before. We had weather reports. We had they could look at the wheels on the train, at the end of the day, but they couldn't look at it in real time and get snapshots of it every 5 minutes or every 10 minutes. All of a sudden now we're getting this huge incremental amount of information coming at us. And so those 4 V's really define the difference between big data and traditional regular data analytics environments. So, and hopefully that leads to why cloud is so important for big data. All of that flexibility that I talked about, all of that not worrying about the need for provisioning in advance is what drives the cloud and big data together. So first off, you get that scale, right? We have the ability to analyze that data and use the power on demand without having to figure out in advance how much computing power that I need to apply against it. And similarly, I have the ability to handle a ton of data in both structured and non-structured ways. We haven't really talked about this, but IT departments typically have a very difficult time figuring out how to load new tools into their environment. But in the cloud, all those tools are already there, provided by AWS, provided by Azure, provided by whoever. And so as a result, you've got access to those tools. And it really gives you that resiliency. The cloud, because you're looking at tons and tons of data at once, that's actually very stressful on your IT infrastructure. But you're getting the power of a reliable environment for it. This ability to respond and react quickly to all that data really drives new value in your business. And I've given a couple of examples of that. But when you take, for example, weather data, and you take data about people's interactions with your store, and you take information about demographics that you have, you can predict. An incredibly trivial example, that it's a good time to buy shovels early in the fall. But there's much more complex and positive items. And when we did a survey recently and looked at where people were using data, and you could see that they're trying to take IoT data and data from digital interactions with their clients and traditional analytical information from existing transactions, and pulling all of that together. And that's the sweet spot of a big data solution. In order to do that, you need in order to analyze that data, you need the computing power that's provisioned through cloud. And again, another real life example. So Suncor, which is a Canadian company, and in the utilities or the energy industry, basically realized that they had all of this data available to them around the plants that operate, and they were looking at 87,000 sensors. And when you think about 87,000 sensors and trying to make sense of what maintenance needs to be required, what safety protocols need to be in place, what I can learn from all those across 900 key metrics, that's a big data problem. And they've taken all that data and built what they call Suncor 4.0, which is a single pane of glass or control tower that allows them to understand what's happening in each plant, when they need to schedule maintenance, when they need to when operations are moving smoothly, when the capacity they have available to them at each of those facilities. It only works in an environment like that when you build it in a cloud environment, in a composable environment that allows you to flex as the data comes in. So I'm going to turn it back to Cynthia, who's going to talk about our second example, which is actually pulling all that big data together So Cynthia, why don't you go away? And I'm going to go grab a lozenge for my throat.
Okay, excellent. All right, so so one of the big things that you'll see in your regular life is the change to 5G on your cell phone. And this is a huge change from what's come before. So what this chart is showing us is the difference between, so we started out with 1G, which is analog voice and text, and you could do simple things on your phone, and you move up through until we're in the sort of the 4G area that we're really used to, where we've got applications running on our phone, we're doing things quickly, we're doing things in real time. And then we move into 5G, and 5G takes that capability and allows us to process data in parallel is really what it comes down to. So instead of having single streams of data, we're pushing multiple streams of data to your phone back to the 5G point of presence, and that's all fiber connected back to the core. So we have it's almost unlimited bandwidth to play with here, and this really opens up the capabilities and the ability to ingest far more data far faster than we ever could before. Fine.
I'm back. Yes.
Okay. So really, when you look at it, what we're on the cusp here, the combination of big data, cloud, 5G, and the ability to use AI to work through this data and pull it all together in combination with edge computing is driving us towards this industry 4.0. It's the next industrial revolution, and how we do things with this availability of both excessive bandwidth and the ability to run compute both at the edge and in the massive models on the cloud really is going to change how we do things fundamentally. So we're optimizing latency. We're able to select what data gets aggregated. We can be much more selective about what we use and what we don't use. And we can extend those cloud technologies in a really meaningful and powerful way. Okay, so I've been really thinking about these statistics, because what we're showing here is the cloud that we've just been talking about. We spent all this time talking about the cloud and how powerful it is. Well, the next step is we take all that compute, all of that elasticity, the ability to compose applications, and now we extend that by adding edge computing to it. Now, the edge cloud is the compute that happens much closer to where people are. If you have an industrial center that has thousands, hundreds of thousands of sensors, we can now do some of the most important compute at the edge, so that there's no delay. You don't have to compile that data, send it back to the cloud, have it come back. We can react in much closer to real time with the combination of our edge devices and our centralized clouds. And this allows us to, what we're looking at is by 2025, we're looking at having 75% of the actual compute taking place in these edge compute nodes that near to source. And what's really powerful about that is that it's not things that we're already doing in the cloud. We're not taking things from the cloud and farming them out to the edge.
We're doing new things.
We're doing absolutely new things. This is all things that we don't currently do. Okay, so here's some examples, and I won't go through these in great detail, but everybody's thought of the manufacturing examples. If you've got sensors everywhere, you can know exactly the state of your manufacturing processes. You can catch problems before they become serious. You can adjust. You can have healthcare sensors. You can send people home with heart monitors, and they can react in real time. Telecommunications allows us to connect all these IoT devices to distribution, retail. We know what you're shopping for in the grocery store. They can see your phone as you go by the freezer cases, and the freezer cases bring up ads for things that you've bought before, or things that are similar to things that you've bought. And that's all happening at the edge. And this is just some more examples. There's consumer, entertainment, public safety. All of these different areas are all going to be massively impacted by this ability to both combine compute at the edge with our massive models in the cloud. Okay, so now we'll move on to, I will share my screen and we'll move on to the next demo. Share that. So what we're going to do is we're going to go back into the IBM cloud, and we are going to use a really good example of edge data that we've been gathering for decades and decades, and we're going to compose that into some new formats and display that on an interactive map. And we're going to do that all in 12 minutes. So what we have here is we're going to build an earthquake visualization application. So we have a database that, again, I spun this up this morning. Takes about 3 minutes to create a cloud database on the IBM cloud. This was just an empty database. It's a NoSQL database, so we can put unstructured data in it. So however the data comes in, it will store it and we can work with it from there. We are going to add an application to the top of that I've already provisioned, because they do take a bit to provision. So what I've done is I've created what we call is a Node-RED application. And Node-RED is a tool that allows you to very quickly create applications that work with data, that they compose data, they pull it together, they split it apart, and allow us to create visualizations with that data. So I have that here, and this is the Node-RED editor. And this editor, as I said, it's just a drag and drop editor. It makes the process of building data flows exceedingly simple. And we used to sort of scorn the idea of the WYSIWYG editor, that what you see is what you get, because the code that it generated was usually large and cumbersome, and it wasn't terribly elegant. The new generation of these low-code, no-code tools build exceptionally usable code. So I did go through and create the flows for this. It did take me about an hour to create this. I will freely admit that. But I've just put them in a file here, and we will import them into our Node-RED environment. Just give that a moment. It takes it a second to get everything organized. So the first thing that we do is, what we are going to do is we're going to pull in seismic data from the United States Geological Survey. They gather seismic data from the US and around the world. They've been doing this for many years. They started out, they'd send a guy with a device, but now it's all IoT devices, and they monitor around the globe, and they collect all of this information. They take that information from the individual devices, they amalgamate that into useful information, and then they make that available through an API that anybody can pull that. In our demonstration, though, we don't just want seismic data. We want to combine that seismic data with data that comes from the Open Weather Network. So what we're going to do is take that seismic data and match it to open weather data to come up with our own unique data set. So to do this, we start in here, and this is a publicly available site. And I have this set for day right now, but I'm going to change that to hour, just because when we're troubleshooting, sometimes if you pull the whole day, it doesn't always pull it. So we'll start with an hour, so we're sure we can get it in the time that we have. And then for the weather data, I need an API key. So for this, I have gone and created an account. Create an account somewhere here. Where's my phone? Sorry. Should be wearing my glasses. So I've gone to Open Weather and I've created an account. I've created a free account, and the Open Weather people, if you create a free account, they will give you an API key that you can use to pull weather information for places around the world. So we take that API key and we put it into our flow. And that should, it always wants to say that. And that will allow us to pull the seismic data, enhance it with the weather data, and then we're going to decide what region it is in and clean it up from there. Then where this starts getting fun is we have this dashboard. And all this dashboard is doing is right now, this shows us displaying a map on our dashboard. And then we are calling this get earthquake info here, goes and calls the API that we created on this tab. So that calls there. It pulls this data and it splits it up into areas, and it's going to display it on our world map. It is also going to take this data and it is going to store it in the cloud database that we showed a few minutes ago. And then we're going to build a chart so that we can look at the data in a slightly different fashion than just on the world map. It did originally, this down here, it did originally display the last tweets about earthquakes, but what I've learned is that people say crazy stuff on Twitter. So we've disabled that for now. We'll deploy this application. Just take, oh, that was very fast. And now somebody's going to cooperate with me here. Give me a link. And now, with any luck, we will display, we've had in the past hour, we've had 2 seismic events in Alaska. We can see the details of the event. We can see where it was, what happened, the magnitude of the earthquake. We can also see the current weather, because that was the composed data that we were looking to show. Now that's kind of fun, but I think what we really want to see is we want a more exciting chart. So we're going to go back here and we're going to change this to a full day. And we'll use the API that USGS provided. We will redeploy that application. Go back out here and refresh it. And this will take it just a second. It always takes just long enough that I think it didn't work. And now we have it for across the globe for the entire day. And then we can see that looking at the day's statistics for seismic events, that I don't want to live in Southern California because that is how many events that they've had. And we can see the details individually on each of them. Over on the right, we have the graph that we created on the dashboard with the individual numbers for each of the regions. And we have built ourselves our own interactive map in 12 minutes or less.
So what we're seeing here is the power of access to big data and the ability to visualize it so that we understand what's happening. So you can see how this could be useful, for the specific app could be useful for people who are doing disaster relief so that they know what type of relief to send to locations. Because it's not just about the earthquake, it's also about the weather, right? And do we need to send them, winter clothes, or do we need to send them rain clothes because it's monsoon season, et cetera? And so tying all that information together, but also you're seeing the power of the access to all these different items, that all of this is publicly available information. But your corporation can use it, or an individual can use it to get new insight, not only about where they might like to live in the future, but also anything that's going to change the way they view the world, or the way they go to market in the world if they're a corporation.
Sure.
Okay, so let me just wrap it up fairly quickly. And again, I'll share my screen just to get back to our storyline. So this is really, this really isn't the point of the presentation, but I know, you guys are students. And so what I wanted to highlight is this big data question and the cloud question really are driving a lot of hiring in corporations. And so becoming a data scientist or a business analyst or a data analyst or a data architect are very hot skills in the marketplace today. And most organizations are saying that they don't have the enough of those skills in order to get in order to do the work that they want to do. So definitely an area, if you are at all interested in figuring out how to correlate different elements of data, definitely an area to investigate for yourself. So as I wrap it up, and I only have 2 slides left. I just wanted to highlight a couple of things around the keys to success and what I think we've learned. And so when we look at projects that are successful in the big data world and in the cloud world, it always starts with business value. You have to start with something that you're looking for, and knowing that you're trying what you're trying to look for. But the second point is, as you go along, you're going to learn new insights, and you have to be aware that you have to be willing to pivot and focus on what comes next as you learn new things. We haven't spoken a lot about the underlying technology, but because you're using so much data and you're using so much compute power, making sure that you've got everything automated, it's not manually being run, is going to make you much more effective and cost effective, in particularly. It's really, really important. And one of the ways I say that it's like we used to talk about climate change. Think globally, act locally. You really need to start small and work up and continually add incremental value. But you have to do that within a common architectural framework. So you have to start thinking about where your end goal is, but then build incremental components to get there. Don't try to build the whole all singing, all talking solution all at once. And then for those of you who end up in the corporate world, everything requires understanding what the return on investment is that you're going to get, or some measure of it, but measuring success. In general, measuring success. I wanted to do this. I did this. I got the outcome I wanted, or I didn't get the outcome I wanted, so that you can pivot and fail fast, as we say, learn from it, and do something different. Those are really the keys to success when you're marrying together big data and cloud. So if I summarize, what did we try to present? What did we try to learn in this thing? And I just want to give 6 key points. So on cloud and on big data and on them together. So the first one is cloud is really about on-demand availability of technology. It's the difference between owning a car and getting an Uber. It's on-demand access at my fingertips. And it's a real transformation in how IT is working and how IT works with business. And any existing company, any large corporate entity is going to mix cloud and non-cloud for years. That's the hybrid cloud environment that we're living with. When I think about big data, it's not just more data. It's really unstructured data that comes from all sorts of different locations and all sorts of different avenues. And frankly, that the way we've managed data in IT traditionally has not been able to manage. It's a whole new way of looking at all that data and aggregating it together to get new insights. And those 2 things, cloud and big data, are really only the 2 of the trends that are transforming how IT works incredibly rapidly, and probably the biggest era of change since .com, which is 20 years ago. And they really work well together. Big data needs cloud in order to be able to manage the volume and the complexity of the data that they're looking at. And if you want to be successful in this business, as I just said, it's really about trying, learning, adjusting, and repeating. You've got to be agile. You've got to evolve. either as new learnings are identified or as new data sources are available to you to be able to get incremental insight. So that's really our story. I think we've got a few minutes left for questions, if there are any questions at the end.
Thank you so much to both of you, Mark and Cynthia. And Cynthia, you make that all look so simple. I'm sure it's a lot more complex than that. But I just want to just have a quick question. A lot of companies are moving towards increasing focus on sustainability reporting. There's the financial statements, and now a lot of companies are doing the sustainability reporting. And I was interested by the little exercise that you did, Cynthia, with the earthquakes. And it's interesting. So we now have an international sustainability standards board that's trying to put some standards around that. And when they say, like, you've got to disclose all these risks, things like earthquake risks or whatever, and they say you have to have reasonable, supportable evidence that's available without undue cost or effort. And I love that phrase. But in your world, this is not that hard to get this kind of data, to make that little map. Cynthia, again, you made it look so simple, but I know you spent a couple of hours before prepping it, but wow, like you tapped into real live data. We can get live stuff. That's without undue cost, I think, unless it costs like $1 million to get access to the IBM cloud. But yeah.
Well, so I know I touched briefly on the Suncor example where they had 57,000 sensors in their environment. That's information they needed to manage their plants already. That's also the information they need to be able to confirm that they are not, polluting, or that they are meeting their, their output metrics to the, to the government, right? So you're exactly right. It's taking the data you already have and being able to use it in a different way to demonstrate, your compliance, or, if you're non-compliant because, people have accidents or whatever, how you've contained that and resolved that problem.
And it's a question like,
absolutely.
So some people, will have this. And then how can you, if you haven't moved down your digitalization path, for instance, how can you sit there and argue you can't get it? You can get it. The tools are all there. There's people like IBM who will help you do it. It's really a huge step. This is a big deal. This is really a big deal for reporting.
I think it is, so I had a recent conversation with clients who were talking about the, we're not there yet, but the ability to do real-time compliance reporting. In other words, the auditor comes in today, here's what's exactly happening right now, not here's, audited reports from 3 months ago, 6 months ago that they had to manually create. No, let's just look at the system as it's running, and you can learn what's happening.
That was exactly my question. So it's funny you say that, Mark. So when your whole presentation, Cynthia, thank you, Mark, thank you, that was excellent, was this concept of on-demand financial reporting. And I know, we've toyed with the idea, right, Eileen, and to get more relevant information quicker, faster to stakeholders would be so useful. And everything that you were doing, I kept in the back of my head, I kept saying, we finally have the ability to have on-demand financial reporting. The question, though, ultimately, and I think I asked this last week and asked it 2 weeks ago, but how do we get assurance on this, right? So how does the auditor get assurance that this on-demand financial reporting is accurate, is useful, it's a tough question, but I have to ask.
Well, I'd love to hear what the other answers were here, and I think one of your future speakers is from from the legal profession, and probably
Yes.
I'd like to hear their answer too. But my understanding of how audit works, and I'm not an auditor, is increasingly they focus on, obviously they focus on the results of the data, but they're also auditing the system. So they validate that when I say that this data is coming from sensors in a plant in Fort McMurray, that they can actually validate that here's the sensor and here's the connectivity and here's the result, right? It was -2 degrees when I was there, and the system says it was -2 degrees. That I got the right data from the system. So once they validate that it works, which obviously is a point in time thing, then they know that they can trust the data that is coming out of the other end of it. So they don't have to read every single, element of, which would be billions and billions of pieces of data. I've audited the process and I can trust the result that comes out of the process. And I've sort of simplified it when I, talked about sort of the physical component, because it really, the big part is how that data is analyzed. And so understanding the algorithm that's used to analyze that data is actually the hardest part of that. Much more complicated than tracking that the sensor is actually the right sensor.
And you can analyze the process at any given time, right? It doesn't, we're going away from that typical busy season that we see in accounting, which I think would be very useful, very interesting.
But also for environmental, like it's the exact same issue for environmental or financial. Right? So absolutely.
Mark, I have another question, and this is probably simplistic, but we saw Amazon came out with their earnings last week or early this week, and we know that AWS is a high margin business. It's really growing fast. What's the business reason for having multi-cloud providers? I know you guys talked a little bit about it, but why would a company, go with AWS and then go with Azure and then go with IBM Cloud? Is it capability? Is it timing? Is it constraints? What's the logic for not just sticking with, let's say, AWS?
So first off, we're the consultants in IBM, and we're happy to work with all the different clouds. So if somebody wants to stick with all AWS, we're fine with that. By the way, like we're happy to do that. We have lots of clients who want to work that way. I will tell you, most big companies are already multi-cloud, and the reason for that, there's a bunch of them. You're using Azure because you bought Office 365, and it comes with Azure. You're using Salesforce, which runs on, which is a third-party cloud on the SaaS layer. You're using Google because they did some really great work on an analytics early, and so all your marketing data is on, or your marketing analytics is happening on Google, but then it has to connect to Salesforce. And then you said, okay, I'm going to standardize on AWS, and so all your core IT systems are starting to move to AWS, but they've still got to interact with all those other things that you've built in the world. So that's really the reason why it is now. But I think the future, and by the way, like one of the advantages of IBM Cloud, and IBM is a much more of a niche cloud than the other ones that we just talked about, but we've built a cloud that's designed for financial services. And so it's got all the protections that a bank expects in their own IT department, and it's a dedicated cloud instance for them. And we've got another one for telco, for that same reason. And so that's sort of our focus, is building it with the security and the regulatory compliance that those particular industries are looking for. But the reality is, if you went on AWS or you went on Azure, all the functionality or the vast majority of organizational capability you could implement on any one of those clouds. But when there's a new innovation that comes out, let's say you've standardized on AWS, and you then find out there's this really cool feature on Azure, that only exists today on Azure. Sure, in 2 years, AWS is going to copy it, but if I want that now, I've got to build out on that other platform. And that's really why you need to be able to work in a multi-cloud world, and why that concept of having a hybrid common platform that you can actually use to deploy your applications to the others, that really helps. So is that clear?
Fantastic, Mark. Well, I just wanted to again thank you both for a wonderful presentation. I know we post this online, and this was beyond amazing. So thank you.
Yeah, thank you so much. I learned so much, and probably have a few follow-up questions for you. So, but wonderful.
Anytime.
Thank you again for spending the time with us. And again, this will be recorded. It'll be on our website if you want to go back and listen to some of it or all of it again. And stay tuned for number 6 next week, which is data privacy and cybersecurity. Once again, thanks, Mark, and thanks, Cynthia. Great job.
Thank you.